All right, good day, everybody. So in this video series, I'm going to go over Python built-in functions. And I'm doing this video series because I recently did a technical interview, which I'm pretty sure I bombed. And since had the opportunity to speak with a senior developer who's been in the industry for a while, I said, hey, what feedback could you give me to become a really good developer? And he said, just learn the built-in functions for Python and know them really, really well. So as I'm going through and learning them, I figured I'd record a video series so maybe it would help a couple people. And also later on in life, I can review it and remember them myself. So a couple of resources that I've used is I really like Real Python's built-in functions, a complete exploration guide here. I think it gives some really good examples and worth a read, especially if you're working in Python a lot. The other resource that you'll obviously use is the documentation for Python. And in this video series, I'm going to break up these by alphabetical order. So today's video is going to go over all the built-in functions that fall in the category of A. So we've got abs, aiter, all, anext, any, and ascii. So let's go ahead and get started. Everything we're going to do today is in Jupyter Notebook. And the way I'm going to go through this is I'm going to explain each built-in function, and then we're going to run through some simple instances of them. And then we're going to try to use a real world use case because I think it's helpful to not just know some of the syntax where you would, your return values are, but okay, where would I actually use this? Now, as we get into some of the more complex built-in functions that work with asynchronous operations, the real-world use cases become a little more far-fetched in terms of what we're going to simulate. Because I want to keep this simple and I don't want to build out a full-up application or start working with APIs, we're going to hard code a lot of things. But I think if you keep your mind open, you'll see where you might utilize these built-in functions, especially when you're dealing with streaming data. All right, so the first function that we're going to work in is abs. So this one's probably the easiest one of the A group. It returns the absolute value of a number. So the argument might be an integer, a floating point number, or an object implementing the abs function. If the argument is like a complex number, it's going to actually return its magnitude. So for this use case, I'm going to go ahead and import decimal and fractions so that we can use both of those in our instances. So let's start with just a negative number, a whole negative number, and it returns 4. Epic. So now let's go ahead and use a decimal, and let's return a negative decimal. Awesome. And let me add another row here. Let's go ahead and do a fraction. And let's do a negative fraction, like negative 1/2. Nice. All right, and let's do a complex number, right? Because it returns us magnitude. So let's do complex, and let's do 2 plus 3j. And I don't have the plus, I have an underscore. That would mess things up. Let's see what it returns. Perfect, it returns 3.6055 and some change. All right, so now where would we use the absolute function in a real world use case? So what's kind of interesting is if you are a data analyst or statistician and you've used scikit-learn's metrics module, you've absolutely used abs underneath the hood. So it actually uses it uses the abs built-in function for Python in its mean absolute error. So let's go ahead and simulate this. So we're going to import it. I thought this was kind of ironic and wow, why didn't I ever think of this type of thing? So we're going to hard code some of our values here. So we're going to do y true. We're going to just do a list of hard coded values. And we're going to do our predicted values as another list of hard-coded values, 12, 18, and 33. And then we're going to save our mean absolute error to MAE. We're going to invoke this. And we're going to pass in y true and y pred. And let's print. It's obvious I should probably practice my typing. Print MAE, and there we go. So I thought that was kind of interesting, something that I didn't even realize that scikit-learn used the absolute built-in function underneath the hood. So what's another use case where we could use it without importing another library? So let's say we want to calculate a distance between 2 points on a plane, right? Calculate, I can't spell either, the distance between coordinates in a grid. So let's do x1, x2, and we're going to do 4 and a negative 3. And then let's save this to distance, and we are going to pass in x1, and we're going to do the opposite. So we're going to do negative x2. And we are going to print a distance. And what do we get here? We get 7. And there you go. So there's a few use cases in where you would use absolute value. All right, so our next one, I would say, is one of the more complex one, but incredibly useful. Aiter stands for asynchronous iterator. It's a special helper function when data comes in slowly over time. So think of streaming music, streaming videos, messages, or any type of sensor data, especially for IoT devices. So because aiter is going to work with asynchronous functions, typically through an API endpoint, or maybe if you're using a streaming service like Kafka, you would use it in relation to those. But I don't want to build out a full of application hooking those items in. So we're going to simulate this for our real world use case. So here I do have to import asyncio and import random. And what I've decided to do was create a fake chat stream service as a class. So inside the class, I'm going to initiate that with some messages. I'm going to reset the index so each new loop starts from the beginning, okay? It means that the class instance will yield the message literally like a brand new iterator. So then once we get down here, we use stop async iteration when the messages received are equal or more than the length of the messages in the hard-coded list. We implement random to simulate a delay in the messages. It adds a little bit of time delay before sending the next messages. And then down here, we grab the current message by the index and move the index forward by 1. So the next time it gives the next message, and then we return the message. So let's go ahead and move down. Here I've created like a chat stream with some hard-coded values. And then I invoke this new object that will stream those messages based off of the class that we created. And then here's my actual function call. So when we invoke run chat, it's going to go async for each messages in the chat stream. It's going to print chat stream for each message. So what it will do is it will iterate over each message slowly as it comes in. So let's go ahead and run this. And the iterate just literally prints each chat stream message. So I know this example is a little far-fetched for being hard-coded inside a Jupyter notebook, but I think the big takeaway for this one is if you're using any type of data that's not already present for the program to access, and it has to receive it at a variable stream, right? Like through an API, you might use aiter along with asynchrono. So now let's go over all. All is going to return true if all the elements in the iterable are empty, or if every instance is truthy or a non-empty string. So this is really important here that we review what counts as false in Python, because if every instance is truthy or a non-empty string, it's going to return true, right? So the values that count as false in Python. So if you're using Boolean, false is going to return falsy. If it's a none, it's going to return false. If you have 0 for any numeric value, it's going to return false. If you have empty strings, it's going to return false. And if you have an empty collection, whether it's in a list, a dictionary, or a set, it's going to return false. So let's implement a few simple use cases here. So let's do all. It's going to go through and check every single iteration. We're going to pass through some strings. String, and let's do Bob. So every single string is there, right? So it should return true. It does. So now let's do all, and let's pass through some more strings. Let's do hello. Let's do an empty string, which is going to return. The empty string is considered falsy. The other two strings are considered truthy. So because not all of these are truthy, it should return false. There we go. All right, so let's give another quick example. So let's say we want to check if all of the characters in a list of names are present. So let's make a list. We'll say names, and let's give the first name is Bob. Let's do the next one is Sally, and then the next one is empty. So here's our list. Now let's check to make sure every single name in that list, the number of characters is more than 0. So we're going to do all len of the name is more than 0 for name in names, right? We're going to check through each iteration of the names, and it returns false. And the reason it returns false is because, remember, an empty string returns false. So all checks to make sure if every single element in an iterable is true. It has to be true. So in order to make this true, we would have to make sure it gives it a, let's do Coco. And now it's going to return true. So what type of like real world example would you use for this one? So let's say we want to do, let me add another line here. Cool, we're gonna do it above it. There we go. Let's say we want to check a server's health, right? Check a server's health status of several servers. So we're gonna hard code this. Server health, we'll make a list of some pretend servers. And we'll say server A, we'll say it's true. Server B, we'll say is true. And then server C is false. So one of these is false, so it should return that this is false, because remember, not every single element in the iterable is true. So we're going to say if all server health values print all servers are healthy, right? Else print one or more servers are down. let's run this. Yep, so it prints one or more servers down, because remember, all checks for every single element in an iterable to be true. If we change this to be true and we ran it again, it would return that they're all healthy. All right, so that is all. So now let's go through any. Any is very similar to all, except that if it's empty, it's going to return false. So let's go through some really simple use cases first. So let's do any, and let's just pass in some integers. Now remember, oops. 0 is false for an integer, right? But 1 is true. So any is going to return true if any element in the iterable is true. I got to change that from markdown to code. Sorry about that. So it returns true. So now let's do another truth. So let's use strings. Hello. That's going to be true. Empty string is false, but remember we've got at least one true in here, so it's going to return true. True. So now let's get some instances of where it returns false. So any. Let's pass through all zeros for integers, which zeros are all falsy for integers, and it returns false. So now let's go ahead and pass in some empty collections. If you remember, empty collections are false, and it returns, well, it helps with its code. And it helps if I have my brackets correct for my list. It returns false. All right. So now, when would we actually use any? Well, there's a couple different real-world use cases that we could do it. And one of them is, let's say we want to check a password rule checker, right? So I'm going to hard code a password. And then I want to make a list of rules that we got to check against. So I'm going to use any here because I want to check if any one of the characters in the password matches any of the rules. So the first thing I'm going to do is any, if any character is upper for a character in password, or any character is lower for a character in password, or if any character is a digit for C in password. And then finally, if any character in, we're going to use some of these awesome special characters. If any of these characters match of my special characters for character in password, those are our rules that we got to match. Now I'm going to combine any with all because it will pass if any of these characters match, but I only want it to be a strong password if all of these rules come back true. So if all rules print password is strong, else print password is weak. So because our password doesn't have a special character in it, it should return weak. Nice. Now let's change this and let's add a special character and recheck it. Password is strong. So I combined any and all. I think this is a really great use case and kind of helps solidify how you would chain together some built-in Python functions. So let's do another one. Let's say our user must have at least like two-factor authentication, fingerprint, or a password, right, to get authenticated. Now, you're not going to hard code these, but for the sake of this video, we're just going to hard code some list of values. So we're going to say user security equals two-factor. We're going to change this to code. And that just took away everything. Nice. Okay, so let's go ahead and do this again. User security equals, gotta love Jupyter notebooks. Okay, two-factor. Say it's false. We're going to say fingerprint, right? We're going to do fingerprint. Say it's false. And then let's say passcode is true. So now we're going to check if any of the user security values print access granted, print access denied, right? Let's go ahead and see what happens. Access is granted because it's checking if any of these match. Now, if we said if all, right, access is denied. So any will check if any one of those are true. All is going to say all of them have to be true. All right. So now we've gone over any. Let's move to anext. So the best way to think of anext is to think of it as like the next function, but for asynchronous iterator. So again, this is one of those that work with data sources that come in over time that might take time to respond, like APIs. Again, we're going back to chat feeds, right? We're going to use it with async or inside of an async function so that the anext is awaited, meaning it only works inside async functions. So these two go hand in hand together, kind of like the aiter, which stands for asynchronous iterator. So in order to make an example of this, I went through and created like a simple generator of, so the best way to think about this is like pretend you're waiting for a package to arrive, right? And you don't want to stand there at the doorstep and sit there and wait to see if the package arrived. Instead, when the package has arrived, you get notified, right? Kind of like if you order something from Grubhub or, one of the grocery store delivery things, you want to get notified of when it's arrived instead of you having to sit there waiting by the door. So this one generates just simple packages that come through in the async iterator sits there and awaits for the next one to arrive. And when it arrives, it will notify you. So let's go ahead and run this. So it goes through and says package 0, package 1, package 2, and no more packages. So I know this example is really loose. It's pretty difficult to find something that simulates like an API or chat feed that's coming in through Jupyter notebooks to keep it simple. But again, just think of aiter and anext as having to do with asynchronous functions, and you're going to use it with like API calls. So, and if somebody else has better examples, please drop them in the chat. That would be amazing. So this one is one of my favorite ones. Ascii takes a string and turns it into a version that's only made up of basic US keyboard characters, so letter, numbers, and symbols. Anything like an emoji, backslash u xxx, right? So this is really helpful, especially if you're doing data cleaning, because especially in today's world where we have like the emoji keyboards and you're trying to use Logger to capture things, you need those emojis stripped out because you can't do any data analysis on emojis, right? It has to be one hot encoded into numeric values. So let's do some simple examples. Let's do SCSI and let's do hello. And it's probably just going to return, oh, it should return just hello. Yeah, it works, right? So now let's do a SCSI and let's do one with an emoji. Hello, and let me bring up my emoji keyboard and run it. And there we go. See how it's changed the emoji into like an escape character, right? So I think this is really, really helpful when we're going to do some data cleaning, and that's the real world use case that I'm going to use. So let's say we're logging chat messages, but we need to remove any non-ascii characters. So I'm going to say user input equals hello from, and let's pop up, open that. Hello from the United States, right? And we want to change it to like a safe log, right? And we're going to apply to the user input, and then we're going to print our safe log. And sure enough, there we go. So it's stripped out that emoji and changed it into some escape code. So then you can continue to do some data cleaning and strip that out. So you just literally get hello from, right? I think that is a really useful built-in function. I think it's one of the most helpful ones, especially for data cleaning. So this concludes going over all of the built-in functions that fall under A for Python. Thanks for watching and happy coding.